Everybody, this is Iris. I'm presenting today your position for art energy in LU with lithium ion. I hope that everybody is hearing me well and good, and so we can start the discussion. Perhaps if some of you can just send me a chatter to say it's okay for the sound, it will help me to know if you understand and if you listen to me. Yes, it's okay. So I will start the presentation regarding our position in LU. So today, regarding technologies, in emergency lighting, we can use either lithium or iron phosphate. Art's energy position is to use iron phosphate for different reasons. The first one is for performances. Performances, today we have tested since few years different type of lithium, lithium ion, lithium iron phosphate and other, regarding permanent charge at 60 degrees C. With this permanent charge, we can see that lithium ion, quite standards such as NCA, LCO, NMC, are stopping early in the test, within the 16th first month. We have some cells with a very good behavior, what we will call high hand, and it's Murata tape. So Murata is the same as Sony because they have bought the company last year. And then we have a third part that are most cost attractive LFP or iron phosphate, made mainly by Chinese one. And so we have a large range of cells, but those can do the jobs. So regarding this test, we have tried to select a lot of manufacturers, and we have started a test at 50 degrees C with intermittent charge to try to select good performances. As you can see on this graph, we have a large range of performances. That means that all sources are not at the same level. And so some can be good for 4 years duration, as it is requested in emergency lighting, but some are with poor performances. So based on those tests, we have selected some types for emergency lighting. So this is the first reason why we have selected iron phosphate. The second reason is for safety. We have conducted last year a test for fire exposition of some blocks, luminals, in condition of a fire in a building. So we have used a completely charged battery pack from different technologies, nickel metal hydride, nickel cadmium, NMC, LCO, NCA, and iron phosphate. What we can see is that with NiCad and nickel metal hydride, there is nothing happens, the fire is still the same. With NMC, LCO, and NCA, even with a very small batteries, only one cell, if there is a fire, with the battery inside, there is an explosion with projections of parts of the cell. So it's increasing and it is more dangerous for people coming for stopping the fire. With iron phosphate, there is no projection. In fact, the cell is behaving as a blowtorch, and it's just an increase of fire power for some seconds, some tenths of seconds, and then it's okay. It appears as nothing. So that means that from a safety point of view, iron phosphate is much safer to be put in a fire than lithium ion standards. That means for us, regarding the usage of emergency lighting, lithium iron phosphate is really the best compromise in the lithium family. But nickel metal hydride and nickel cadmium are quite better because in that case there is no increase of nothing. Nevertheless, the subject today is iron phosphate and emergency lighting. So, what benefits can we have from this kind of technology? With Chinese cells, we can have a 4 years life duration at 40 degrees. That means we can sustain the standard from the LU, and so it's okay. And the TCO, it's lower than nickel metal hydride. For some of them, such as Murata, we can even stand 8 years life at 40 degrees C or 5 years at 50 degrees C. So that means we can have a long life duration, and the battery can be smaller than NiCad, and the block can be very thin, and it could be very interesting from a design point of view. I will show you now some curves for performances of both products we propose. The first one will be the cost-active products, and the second one, the high-end products. Regarding the first cell, is a Chinese cell, it's a 14500 type. That means 14 millimeter for diameter and 50 millimeters for the height. So in this cell, we have 500 milliampere hour. So this is a very small part. It's quite equivalent to a AA cell. The temperature range for the charge will be from 0 to 60 degrees, and you can discharge from -20 to 60 degrees. Regarding charge, you can see that the charge at C/2, so this is a rate we have tested and we have characterized. You can charge the battery from 0 to 50 degrees C without trouble, and the charge duration vary, but globally within 2 to 3 years, 3 hours, you will charge the battery. So this is not a problem. The charge is done by constant voltage, constant current. So it's the same as for the lithium, but the threshold is different, is 3.6 volts. Regarding the discharge performances, we have curves at C/2 and at C/5. At C/2, you can see that the best performances are for temperature above 0 degrees C. That means for very low temperature, -10, -20, you will have a capacity available, but much less than the batteries at room temperature. You will be around 40% at -20 and around 60% at -10. So these cells are better to be used in high temperature or between 20 and 60 degrees, which is mainly the more current usage for the emergency lighting. At C/5, that's sure that the behavior is a little better. At -20, we will reach 60% of the capacity, and at -10, we will reach 80% of the capacity. So that means that this cell at C/5 discharge rate could be a good cell to replace some AA size with a 500 milliampere hour. As you can see, the voltage is very stable during all the discharge, and at the end it's shutting down, the same as you can have on nickel cadmium or nickel metal hydride behavior. Regarding the life duration, you can see on this graph the life duration for one cell, or few cells tested, but one type of cell at 50 degrees C with intermittent charge. The test is still running, and after 70 weeks, we are still above 90% of the capacity, the initial capacity. That means that we are very confident to get 4 years life duration at 40 degrees. So we tested at 50 degrees because if we have a test with a higher temperature, in that case, we will have some degradation of the cell, and so we cannot measure the aging of the cell safely. We can only measure the degradation. So that means that's why we have some tests started long ago, and now we have results that we can share with you. For the 18650 cost attractive cell, we have a capacity of 1.5 ampere-hour. In that case, the diameter is 18 millimeters and the height is 65 millimeters. The temperature range is the same as the AA, so we can use it in the same range. For the charge, as you can see, with a charge at C/2, we have a full capacity charge with less than 3 hours. So it's not a problem, and it's very interesting. And for the discharge, so we have, as we have seen for the AA cell, we have performances at C/2. And in that case, the minimum capacity we can reach at -20 is 48%. And it's quite 70% at -10, and very good capacity at between 20 and 60 degrees C. So it's a very interesting curve. And C/5, we can have minimum 60% capacity. So for some application, it will be low. I know that if you have some application in areas where the temperature is very low, such as a fridge and so on, it's very difficult to have some good behavior. But mainly for most of the application, this is okay. And here we can see also that the voltage is very flat during all the discharge when the temperature is higher. The life duration, with this cell, we have a test at 60 degrees C, so 60 degree is much higher than 50 degree we had on the last cell. And we have here 22 months duration. So that means that we have 2 years, a little less than 2 years at 60 degrees. So that's why we are very confident to get 4 years at 40 degrees. In 18650 size, we have also a high-end cell available. The capacity is much lower than the cell we had with the cost-attractive type. Here we have only 1.1 ampere-hour with the same size, or quite the same size. There is some tens of millimeters difference. The temperature range is still the same. So we have charging curves between 0 and 50 degrees, the same as the other. So it is compatible depending on the cell you choose. You can have the same charge system. And for the discharge, at C/2, we will have a voltage behavior that is a little different depending on the temperature. So the voltage is not exactly at the same level. So that means that if you need some alert regarding the voltage, perhaps the level will be much difficult to place on this cell than for Chinese cell. It is the same behavior at C/2 or C/5. The minimum capacity in that case at C/2 is 50%. And you can have 88% at 0 degree. So that's a good performance. At C/5, the minimum capacity will be 65% at -20. And here you can see also that the voltage level is a little different depending on the temperature. So this is a small difference between Chinese cell we have on one side and the Murata cell we have on this side. For life duration, our testing on this cell is at 38 months at 60 degrees. So it's a very good performance. It's very robust. And the test is still ongoing, so we haven't stopped it. That means that the battery is still in function, and after 38 months, it's very long durations. That's why we are very confident to last either 4 years at 50 or 8 years at 40 degrees. So this is the very high-end cells for very robust applications. Then we have the last size. It's 26650. We have either a cost-attractive cell, about 3.3 ampere-hour. So in that case, the diameter is around 26 millimeter and the height about 65 millimeters. As for the previous one, the charge system is the same. So it's a 3.6 volts charge, and you can charge within all the battery, all the range. And for the discharge rate as C/2, you will have, in that case, a voltage difference regarding the discharge. It's more important than on the smaller sizes. And the minimum capacity will be here at 54%. So it's interesting to have such a cell, but the minimum capacity at -20 is perhaps a little lower than what you need. In terms of life duration, we have not curves with permanent charge on this cell, but we have curves for cycling with 50% depth of discharge at 50 degrees. And in that case, we can last more than 4,000 cycles of life duration. So it's very long. And for us, it's a sign, or it's a value that shows a very high performance. For the high-end cell, which is Murata cell, it's only 3 ampere-hour. The charge is the same, so I will pass quickly. And the discharge at C/2 rate is quite better than the Chinese one, because we can reach 61% minimum capacity. But the voltage is very low, so you have to take care of this voltage for your threshold. And for the behavior, we have the same behavior than the high-end 18650, so I haven't put the curve here. So this is the data we have collected since a few years. Regarding the charging method, the method will be the same as for some other cells. Iron phosphate. The charge is an intermittent charge based with a voltage and a current, and then you can stop the charge when you reach the end of charge, and you can restart the charge when the battery reach a voltage threshold you have selected before, or every 2 weeks, for example, or every month. So that means you have an intermittent charge. The battery is not kept at a high voltage source for a long time. So this is the difference between for this technology regarding the other one. In nickel cadmium, you can have a permanent charge. Nickel metal hydride, you will have an intermittent charge. And for this kind of technologies, iron phosphate, you will have also an intermittent charge. The only thing is that you cannot charge when the temperature is negative. That means you need to manage the temperature during the charge. And if you need to use the battery in charge in a cold temperature, then you have to had a heater. So here is a summary of the whole product range with the three types: 14500, 18650, and 26650, depending on cost attractive type or high-end type, and the duration you will have at 40° or 50°, depending on the type. So this is a summary of what we can propose. And all products must include a protection board for safety. In our position, the technology iron phosphate need to have a protection board to maintain a good safety of the product. The electronic protection will deliver as a minimum overcharge protection, over discharge, over current, and short circuit. Our PCM also integrates NTC for the temperature management. That means you can manage temperature for charge or for discharge if you need, but you have it on the products. Here you have some examples of batteries, standard battery type, 1S, 1P, 1S, 2P, or 2S. So this is some kind of product we can propose and we can build with different capacities depending if we are using a cost attractive one or a high-end product. So as a summary, in terms of technologies, our position for emergency lighting is to use iron phosphate and not lithium ion standards, to use nickel metal hydride and nickel cadmium. And for iron phosphate, the life duration we have is 4 years at 40°. Oh, yes, and 8 years at 40° with Chinese cells, or even 4 years at 50° for the Murata one. Our roadmap, you can find it on our website, is this one. So you can find the different kind of cells we can propose depending on the applications. So here is the end of the presentation. If you have questions, you have a question box available on the tool. So please use it, and I will be happy to answer or to give you indications about answers I can give you. You can also use even the chatter if you prefer, but the question box is good. So I have a first question about the minimum cutoff voltage for the battery. So today in the application, in our testing, we cut the discharge at 2.5 volts, and we set the protection board protection for under voltage at 2 volts. So that means there is some gap, so you can go down to 2.3 volts in discharge. The warranty length is a question also about what is the warranty. So this is something to discuss with our commercial team, sales team. Today our standard is 1 year warranty, and then we can have some discussion and some agreement about longer warranty with some contracts. So it's possible to discuss. In the presentation, so the graph we have presented are issued from our testing on cells we have done since a few years. So all the testing, the graph we have seen are made with the battery we propose in the offer. A question is how we manage the charge below 0 degree. In fact, in the battery PCM, we have no charge management. We have only protection for overcharge, over-discharge, overcurrent, and short circuit. The battery pack integrates a NTC so that the blocks, the luminaire, will manage the charge. You have two possibilities to manage the charge. The first one is to say, when my temperature is below 0, I don't charge. Because in this kind of application, this 0 degree will not occur very often. The other solution is to say, if the battery temperature is below 0 degrees, I have in my luminaire a heater, that means a small circuit board, that will heat the battery first in order to be above 0 degrees and then to start the charge on the battery type. So this is the way to manage the charge below 0 degrees. Can we use nickel metal hydride batteries at 60 degrees with reduced life? So the nickel metal hydride batteries can be used up to 60 degrees without problem. We can use them even up to 70 degrees. The fact is that if you use it with a permanent temperature of 60 degrees, then the life duration will be reduced. But it's not a question of I would say, of working or not working. It will be okay. We have some nickel metal hydride type of battery that can be used in high temperature without trouble. Nickel metal hydride batteries can also be used at below 0 for charging. So the advantage, the benefits is different from LFP. So another question is, what is the percentage of the initial capacity after 4 years? 60%? So in fact, it depends on the cell. If you take a cost attractive 18650 18650, in that case the capacity after 4 years will be higher than 60%. But we say that the minimum to pass is 60% after 4 years. So it will be higher than that. For the high-end product, after 4 years, you will be at a very high level because you will be at, let me check. You will be still at 80%. So with the high-end product, you will be at a very high level. I think we have answered all the questions, and now it's quite 5 and the end of this webinar. You will receive, all of you, an email within 1 day regarding the webinar and the record. So please do not hesitate to contact me if you need some other information or if you have questions. Thank you very much for attending, and I say you goodbye and see you next time. Bye-bye.